They're like, what? It's not working. Okay. One other thing about deletion that's kind of cool. Core data will send the method, send a message, prepare for deletion, to all objects when you send delete object. Okay? So if I say delete object photo, that photo will be sent, if it implements it, prepare for deletion. And the cool thing is you can put this prepare for deletion in a category. So you can add the prepared for deletion method to photo or photographer in a category. Now what would you do in that prepare for deletion? Well, you don't need to do anything with the who took or the photos or anything like that. That's all taken care of for you. But what if you had another property somewhere in the database which was counting the photos or something like that, and deleting this photo would change that count? And why would you have such a thing? Because it's possible to just query the count of photos that a photographer has, for example. Maybe it's a count that for efficiency, you're checking something about the photo and keeping this count. And maybe if you delete the photo, you need to update that count. Well, you can do that, all that kind of stuff here in prepare for deletion. Okay? You can basically do anything in the database you want in prepare for deletion. And the thing that's being deleted is not yet deleted. Okay? So it's still in the database at the point this is called. But after you return from this method, then the object's going to be deleted. So you better have updated the database however you need. Okay? Got that? All right. So now you can create objects with insert. You can get and set the properties. You can delete the objects. One last thing to want to do in a database, query. Okay? Which means go out into the database and get me objects that match some criteria. Okay? So we do this in core data with an object called an NSFetch request. All right? It's exactly what you think it is. You're requesting to fetch some objects from the database. You need 4 things to make an NSFetch request. The entity to fetch, and this is an interesting one because when you fetch from the database, you can only fetch, fetch when you execute it, returns an array of objects, an array of NS-managed objects or subclasses thereof, as you might imagine. That array all have to be the same type of entity. Okay? So there's no way to do a fetch in a database that gives you an array back. Some of the things are photos and some are photographers. They all have to be photos, all have to be photographers. So you have to specify the entity that you're trying to fetch. Okay? Understand what I mean by that? That's the most important thing. In fact, the way you create the fetch request is by specifying what kind of entity you're trying to fetch. Then you can specify optionally how many of those objects you're willing to accept and how big a batch. If you're fetching a whole bunch of them, you can specify how many to get at a time. Because it's not going to, if you say, give me these photos and it matches 10,000, it's not going to load 10,000 things out of the database and into memory. Okay? It's going to kind of give you 10,000 placeholders, and then it's going to fetch them in little batches. And you can specify the batch size depending on how you're going to use the object. If you use the information, if you're displaying a table view, well, you can set the batch size real small, like 10 or 20, however many, scrolling around in a table view, you can only see 10 or 20 at a time. So you can have a small batch size. Okay, so you control that. Sort descriptors, which we're going to talk about, which is how to sort the results, because the results are an array, not a set. So the array means it's ordered. So you've got to specify what order to give those objects back in. And then, most importantly, the predicate. And the predicate says which of those entities you want. Which photos, which photographers. Okay, so let's look at these 4 things. Here's what a fetch request looks like. You create it with fetch request with entity name. That tells you what you're fetching out of there. And then you can set things like the batch size and the fetch limit. They're just properties on the request. And then the sort descriptors is an array of sort descriptors. We'll talk about why that's an array. And then the predicate is NS predicate. So this is how you would set up a fetch request. Okay? Very simple. So you can look up in NS fetch requests how batch size works, how fetch limit works. I'm not going to get into the detail about that for time reasons. But I am going to focus on sort descriptors and predicate because those are really important. So let's look at the sort descriptor. You create a sort descriptor using this class NS sort descriptor. And it has quite a number of class methods to create it, so you should go look at the documentation and familiarize yourself. But they're generally of the form sort descriptor with key. So that's the key you want to sort by. So if I were fetching for photos, I might want to get the result sorted by the title of the photo. That would be a classic thing. Ascending is whether it's alphabetical order or reverse alphabetical order. And then the selector is interesting there. That is the method that will be used to compare photos while it's sorting them. Okay? So it's going to sort the results by the title, and it's going to be using the method here, localized standard compare, to compare the titles to know how to sort them. Okay? Now, what is localized standard compare? Localized standard compare means sort them like they would look in the Mac Finder, basically. Or that's kind of a colloquial way of saying it, but basically sort them how real people think things should be sorted. Not case insensitively, do the right thing with diacritic marks if it's a language that has a lot of diacritics, that kind of thing. Okay, that's what localized standard compare is. There are other selectors that are sensible if it was a string type property, like localized case insensitive compare, which sounds the same, case insensitive sorting, but the diacritics are handled differently in that case. So that's why you'd want to use standard compare. So you can look up in sort descriptor to see what kind of methods are kind of built in. You can sort by things besides strings. You could say sort descriptor with key upload date, and then the selector would want to be compare colon. Compare colon is a method most things, if not all, except for NSData maybe, things in the database will respond to. Compare colon, it's kind of the default compare. But it's not going to do what you want usually for strings, so you want a better one. But it will work for dates and things like that, numbers, things like that. So that's the selector. You can leave that selector off when you create the sort descriptor. Just say the sort descriptor with key ascending, close square bracket, and you'll get compare. Okay, so compare is kind of the default one you get. Why do we give an array of these things to the fetch request? Okay, when we saw request.sortDescriptors, it was an array of these. Well, that's the old last name, first name thing. If I said, hey, I'm going to fetch some people, some employees out of an employee database, and I want you to sort it by last name. Well, of course, all the Smiths would all sort to the same thing. So you want to then sort those by the first name. So you provide two sort descriptors, one that sorts by last name, that's the primary sorting, and then one by first name is the secondary sorting. Another common one is a table view. Pay attention, because your homework you might have to do this, is maybe I'm doing the table view like you're doing in your current assignment, and I'm sorting, basically by the name of the place in the place one, but I'm supposed to do it by country, sections by country. So really I need to sort first by country. Then I sort by the name of the place in the country. Okay? So that's an example where you might use two sort descriptors. Country sort, then the place. That's so that I can get them in order so that they're by country first. Okay? Make sense? All right, predicate. So this is the guts. This is the thing that says, which photos do I want? Which photographers do I want? And the NS predicate looks a lot like NS string when it comes to creating them. So just like we have NS string with format, we actually have NS predicate with format. Okay? And you can specify this arbitrary string. Now, this is good and bad. The good news is this is incredibly flexible, and you can specify unbelievable kinds of criteria for finding what things you want in the database. The bad thing is it's a little bit for you to learn, because it's almost like you have to learn a little bit of a language here, the predicate language for how you specify what you want to choose. The basic format allows you to do the %@ replacement just like you could with NS string. So here, for example, I'm looking for all the thumbnail URLs that come off of Flickr 5 server. So I'm saying predicate is thumbnail URL contains Flickr 5. But I don't put the Flickr 5 right in there. I use %@ and it's an argument. So I can use %@ replacement. And I can replace not only the right side, what's contained, but I could replace the left side, like which property I want to search to see if it contains Flickr 5. Okay? And we'll talk about contains in a second, but question?
So this doesn't just convert it into a string and feed it into something, right? Like it will recognize, the function itself recognizes this is an argument, this is an argument.
Correct.
Okay.
Yeah, so this is not just, the question is that just making a string and passing it off? And the answer is no. NS predicate is actually looking at what you're parsing. And now it can't know what database you're doing a fetch into, so it won't be until fetch time that it might fail. If you say thumbnail foo contains whatever, predicate's going to let you create that predicate, but then when you go to do the fetch, it's going to say no property thumbnail foo in this database. Okay, so you see this one's contains. Contains means, you know, that string is contained in the other string, exactly what you want. So the contains is one of the words in this little language for setting up predicates. Here's a whole bunch of other examples. I'm not going to teach you all of predicate today. You're going to have to look at NS predicate documentation to see what it can do. But here's a bunch of examples. Obviously, you have equals. So you can say unique ID equals %@, maybe the Flickr object, the Flickr photos unique ID. You can say name contains with square bracket C. That means contains case insensitively. Okay, so that's part of the thing. You can have greater than and less than. So if I had a date property called viewed, I could say if viewed is greater than a certain date, like today's date, for example, or it would be, I guess, less than today's date, or less than today's date minus 24 hours, or whatever. So you can use greater than and less than. You can use dot notation to follow relationships. So you can say who took dot name equals CS193P instructor, right? So you could have, this would be a query or a predicate for searching in the photos entities. So you're trying to get photos entities, but you want photos entities where the who took name is some photographer's name. So the things you're getting are photos, but the query, the predicate you're using to find them, is looking over at the photographer using dot notation. You understand this? Okay, you definitely need to understand this for your homework. And you can do really powerful searches like, give me any photo whose title contains, give me, this would be a photographer query. So let's say I'm searching photographers. Give me any photographer where any of its photo's title contains this. Okay, so that any is kind of a special thing. That means I'm a photographer. Look at in the database at all the photographers. Look through their photos set to look at all their photos. Look at all the titles of all those photos. See if it contains this string, and if it does, return that photographer. Okay. Now this seems, I'm sure you're like, whoa, that is going to take a lot of computing power if I have thousands of photos and hundreds of photographers, but actually databases know how to do this really, really well. Okay, and all this stuff that you're doing is generating stuff that happens on the SQL side. So you're going to get a big SQL statement generated here to join these tables, do these searches. It's going to be incredibly efficient. And one thing to understand about core data is it's very efficient. Okay, the SQL it generates is totally tuned to the max. Okay, having said that, there are certain queries that are more efficient than others that can accomplish the same goals. So if you get to be a core data expert and you start building big databases and you're making a lot of big queries on big data sets, you will eventually learn what makes a good query, what makes a not so good query, etc. For your homework, you don't have to worry about that yet. Okay, let's get the basics first. Question?
I'm assuming with the templating, you can't pass any of these operators in as a %@ sign when you're building a predicate?
So the question, you mean like the greater than and the less than, can I pass that in as a % sign?
Like I'm assuming this is to prevent something like SQL injection.
Yes, you can't do SQL. The question is, can I do SQL injection by using the %@ sign to basically make the operator be, you know, configurable? And the answer is you can't do that. NS predicate would complain about that. NS predicate does know when a %@ sign is a right hand or a left hand of one of these expressions. So the answer is no, can't do that. Okay, so there's a bunch of examples. Again, I'm just trying to give you examples. We're not trying to teach you predicate here. There's also a compound predicate. In the NS predicate, you can say and or. So you could say name equals %@ sign or title equals %@ sign. Okay, if you had an object that had a name and a title. Or you could